Welcome to another video, the same every time, GCSE Maths, looking at the questions that apart from the numbers are the same every time. In these videos we're always looking at exam questions, and you can get familiar with those exam questions. You can see that they really are the same every time apart from the numbers. You learn how to do them, then when you see them on your exam you recognize them. You're straight in there, you get the right answer, you get yourself into the marks, you get yourself into the grades. So this time we're looking at the midpoint of a line. And here's our exam question. The coordinates of P, point P, are -3, 8. And the coordinates of Q, point Q, are 9, -2. Calculate the length PQ. So this time, midpoint of a line, length of a line segment. We're looking at the length of the line joining together the point P with the point Q. And if we were to draw these things on a coordinate grid, we would find it's going to make a sloping line. We could make it into a right-angled triangle. It would be a Pythagoras job, really, but we don't actually need to draw anything. What we need to do is just a calculation, and that calculation is, of course, the same every time. So my 2 points are -3, 8 and 9, -2. So you need to follow the same method, exactly the same method every time. The length PQ, the length of the line from P to Q. If I plot the point P, plot the point Q, join them together with a straight line, then measure it, how long will it be? We've got to calculate that. And here's how we do it. We start off with our x coordinates, -3 and 9. And the first calculation we have to do, bracket, -3, so it's x minus x. So we subtract the x coordinates, -3 minus 9. Put that into brackets and square it. Then we have to add. And now we look at the y coordinates. We've got 8 and -2. So we do the same thing with the y coordinates. We subtract them. So 8 minus -2. We've got to be a bit careful with that minus there. Squared, the whole bracket squared, and then the whole thing inside a square root sign. If you've watched the videos about Pythagoras theorem, you'll recognize this. It's a square, square, add a square root. If we did draw this on a coordinate grid, we would be finding the longest side of a right-angled triangle. But we don't need to worry about that. Just follow the method, the same every time. So typing it into your calculator, looking exactly like that. So just make sure you can do it. If I do it and you do it, and then we compare answers, if we've both got the same answer, then we must both be doing it right. So I've pressed the square root button, then bracket, then -3, take away 9. On your calculator, of course, the button to make something into a negative number is a different button than the subtract button. It's the button up there with the functions. It's like a minus sign in brackets. Anyway, bracket, -3, take away 9, close bracket, then squared. The squared has to go outside of the brackets. It has to look exactly like I have written down here. Then plus, then another bracket, 8 minus -2, bracket, and then squared. So I've pressed equals. I get straight away the exact answer, 2 square root 61, SD button, and I get this. I'm going to write down my full calculator answer, 15.62049935. Check that you've got the same answer, and if you have, then you're operating your calculator properly. There's a lot going on here, isn't there, with all the minuses and the brackets and the square root sign there. Just make sure, a common mistake here would be to put the squares inside the bracket. I've seen students do that. It has to look exactly like you can see here. Check that you can do it. Check that you get the same answer as me. Then you are operating your calculator properly. So I've written my method. I've written down my full calculator answer. And then in these questions, I will always go back and read the question again, because it might tell me to round to a certain level of accuracy, significant figures or decimal places, and that would be worth one of the marks. In this case, it does not, so I'm going to round to a sensible level of accuracy, or on some exam papers, on the front of the paper, it says round all non-exact numerical answers to usually 3 significant figures, doesn't it? But even if it doesn't say that, 3 significant figures is a sensible degree of accuracy, so 15.6, and then just to show the examiner that I have rounded it. But I would make sure that I am writing down my full method, and then my full calculator answer, and then my rounded answer. Now, one thing to say about this, we know that you could literally just type the thing onto your calculator without writing anything down and just write down the final answer. Now, that's not a good idea, is it? So it's a 3-mark question. Some of those marks are going to be for method, so make sure you've got the method down there. It would be so easy to type in the wrong number on your calculator in an exam situation, or accidentally forget the minus sign or whatever. And if you've got the method written down, then really you're covering yourself. You're still going to get into the marks. Anyway, remember how to do this. They're not going to tell you the formula for this on the formula page of your exam. This is the length of a line segment. So the length from point P to point Q. So by the way, a line segment just means part of a straight line from one point to another. In maths, when we talk about a straight line, it's kind of infinitely long. It has no beginning, no end. It just goes on forever. So we do in brackets x coordinate minus x coordinate, outside the bracket squared, then plus y coordinate minus the y coordinate, then outside the brackets are squared, the whole thing inside a square root. It's a Pythagoras situation, square, square, add, square root. Learn how to do it, then when you see this kind of question on your exam paper, you'll know exactly what to do, you'll get the marks. Look at that, 3 marks. Now that's a great 3-mark question if you know what you're doing. If the video was helpful to you, please do press the subscribe button. Please also like the video. And thank you very much for watching. I will return in the next video.